Hello, AP Chemistry, and thank you for joining me for another exercise in the equilibrium packet. I hope the previous one was helpful, and I hope this one will be also. Again, if you do not want to hear my voice because you think I'm annoying, just turn it down, but you can still watch the steps and how to do the problems. I know that I put step-by-step numbers into the packet, but that might be more difficult to go by. So if you want to listen or watch or one or the other, this is where you need to be. So this is exercise 11 on page 9 of your NMSI packet, and I crossed out what the original problem was because it involved using the quadratic equation, which is not necessary for high school AP chemistry, but will be useful and necessary come college. But again, it won't be on the AP exam, so we're going to try to save some time here and now. The problem that I wrote into the exercise 11 is saying that we have chlorium trifluoride in equilibrium with chlorine monofluoride and fluorine gas. And we were given a few bits of information that you can see here, that the initial concentrations, which I am highlighting here by the letter I for initial, are what they say they are, 2.5 molar for ClF3 and 1.00 molar for F2. And we are trying to find the equilibrium concentration for ClF. Another piece of information that we're given here, unlike the last problem, is that the equilibrium constant is 8.77 times 10 to the negative 14th at 279 Kelvin. The temperature doesn't really matter here, but we want to include the temperature because equilibrium is definitely temperature dependent. So we're saying that it's at 279. That doesn't have any effect on the numbers or the values, but we put it in there so that you know that it is temperature dependent. So if we are given this information and we know we're at equilibrium by looking here, the arrows going right and left tells you that it's at equilibrium. We know we're going to have to set up a rice table, and so we will go to the next page to do that. Very similarly to the last problem, exercise 9 on page 8, we want to write down our balanced equation and set up our rice table starting with the R, double line coming down on the arrow, at the plus sign draw a line, and I, C, E, ooh, yikes. ICE, I for initial, C for change, E for equilibrium. We want to write in the information that we are given, so if we look back, for ClF3 initially it was 2.5, and for F2 it was 1.0. So 2.50. You can write M, you don't have to write M, but make sure that you know that this is molarity and not just moles. My F2 was 1.00 molar. And because I'm not told anything about ClF initially, we can say that it is 0. And the one thing that we are trying to find is this ClF at equilibrium. So that's what we want to find. And so we need to remember a couple of things from the last one. And our first step here was initially writing down what we had, and you can follow the steps along in your packet. And our second step is to recognize that we have here a 1 to 1 to 1 ratio again. The next problem that we do will not have this 1 to 1 to 1 ratio, but for now it makes our math easy. So this is our second step to realize that we have a 1 to 1 to 1 ratio. And we need to realize next that our products, which are these guys here, up here, so we call them positive. So we can put I'll put a positive here and a positive here because they are both appearing as products. Similarly, or oppositely, I guess, I can say for the C that it's going to be negative because they're disappearing. Now this next part we didn't do in the last example, but we're going to introduce it now. We don't know how much they are changing. We know that they are appearing and disappearing, but by the balanced equation 1 to 1 to 1, we can say that each are appearing or disappearing at the same rate, and so I can call this rate that I don't know x. So plus x, and minus x. And then again we said that, and so this is our second step, or third step. Yeah, so this is called this our second step in the notes. This is our third step. And our fourth step is adding up I plus c equals e. Alright, so if we have that, get that out of there. Go back to white. This is going to be 1.00 plus x. This is going to be 0 plus x, or just x. So I can get rid of that. And this is going to be 2.5, 0 minus x. Again, just adding these together to get my e. Once you have your equilibrium values under your e down here, we can plug it into our k, because we know that k is equal to the products raised to their coefficients over the reactants raised to their coefficients. And we will start that on the next page. Ooh, lined paper. Okay, can't use white now. Let's try boring black. And we said that k is equal to the products raised to a coefficient over the reactants raised to a different coefficient. And in this case, that is going to be the products, which were CLF and F2, over our reactant, which was the concentration of CLF3. And because we don't have any coefficients, these are all just going to be 1s up here. Don't need to write 1s though. And now we can plug in some values. So with our equilibrium values, we know that the E here was 2.5 minus x, x, and 1 plus x. So I'm just going to plug those values in. And I have k, which we said actually before, k is equal to 8.77 times 10 to the negative 14th. And so I'll leave that aside for a second. So k equals the CLF, which was just x, and I'll put it in parentheses, times the F2, which was 1 plus x, 1.00 plus x, over my CLF3, 2.5 minus x, and I will plug in the value now for k, which is equal to 8.77 times 10 to the negative 14th. So this poses a problem because we have x's in a couple different places, and if you notice that from algebra, if you do this, you're going to have to FOIL, and you're going to get an x squared in there, and that's annoying. An x squared over x and all these other numbers, it's going to be a pain. So simplifying this in AP Chemistry in high school, we are allowed to say when your k is so small, so because this k is to the negative 14th power, we can say that this x here and this x here can be ignored. So it only works when the k is very small, but we can ignore the plus x here, ignore the minus x here, and it simplifies our mathematics. And so we can rewrite this as x times 1 over 2.50 equals 8.77 times 10 to the negative 14th. Okay, so then that's going to be just x on the top over 2.50 is this here. And so I'm going to rearrange that a bit, solving for x, and when we have something on the bottom, I need to multiply it over. And so 2.5 times 8.77 times 10 to the negative 14th. I'll go to the next page of the video. So 8.77 times 10 to the negative 14th times 2.50 equals k equals, in the calculator, 2.19 times 10, yikes, to the negative 13th. And so this is equal to, is equal to x. So we solve for x. But x doesn't tell us what our concentration of CLF is, because initially we were trying to solve for the concentration of CLF at equilibrium. And so if we take a look back at our Rice table, so going back 2 pages, if we take a look back for CLF in our Rice table at equilibrium, we can see that x is the value that we need for equilibrium of CLF. So it's not 2 times x, it's not x minus something or something minus x, it's just x. So in this one, it's nice that we can say that indeed CLF at equilibrium is equal to x, and so CLF at equilibrium is 2.19 times 10 to the negative 13th molar. In a quick recap, this is how we want to solve for an equilibrium concentration of a certain product or reactant when we are given the equilibrium constant value. Excuse me, I made a mistake here. This is going to be your x. So when you have a k value, which is here, and you have initial concentrations, we can solve for any equilibrium concentration using this x technique, as we can see here. We can get rid of the x's when they are added and subtracted. When our k value is small enough, times 10 to the negative 14th. You can even say times 10, something like times 10 to the negative 5th would be viable for small enough. So we can cross out the x's and then just do some simple algebra to plug back in. We realize that in our Rice table here that x was equal to the concentration, and so we didn't need to do anything else. And there we have it. So the AP exam will ask you many questions on finding certain concentrations, maybe at equilibrium or initially, and this is how we do it. Please email me if you have any questions. I will also be making a video for exercise 12 on page 9 right below it. So tune in for that one if you still need help. Thank you very much. See you soon.